Hello, everybody. Today we're going to be talking about quadratic functions. You may have already heard about this in your college algebra class, but today we're just going to go answer a few examples for entertainment. Well, I can't really say it's entertainment for the most part, but it kind of is. Okay, so let's start. Okay, so in graphing quadratic functions, we're going to use the axis of symmetry, what we call the axis of symmetry, the vertex, the y-intercept, and the x-intercepts, okay? So what happens here is first we need to know if our parabola, or the curve that we're going to be drawing on the graph, either opens up, okay, like that. By the way, this is all credits to GoTutorMath for this method. You guys should check out his channel as well. So here is the parabola. Sorry for the kind of hideous drawing. It looks like a smile. Okay, so we have to know if the parabola either opens up or down, and we're going to know that by looking at the x, okay, by looking at a, because this quadratic function basically just follows the ABC pattern. Essentially, we're just going to check if the first number here is either greater than 0 or less than 0. So as you all already know, in algebra, whenever there is an x, there is an invisible 1 beside it. Okay, there is always a 1 beside it. So what is 1? Is it greater than 0 or is it less than 0? It's greater than 0, meaning the parabola we're going to draw later will be like this. Okay, it opens up like a smile, you know. So afterwards, after we figure out if the parabola opens up or down, we have to know the axis of symmetry. This is going to be very simple. All you need to do is use this formula. Okay, that's a constant formula. So we have to figure out the variables first. What is b in this quadratic function? We know that a is 1 because there is a 1 here. Then what's b? Exactly, it's 4. Okay, so let's write down 4 here. Then 2. Now we need to figure out a. As you all may have already know, it's 1. Okay, so now we just have to simplify that. Okay, negative 4 divided by 2, that is equal to negative 2. Okay, let me see if I'm right. Let me see if I'm right here. The axis of symmetry. Okay, so we had kind of a mix-up with the signs. Apparently, you have to substitute this signs as well. So let's go here. Let's rewrite that. But the denominator is already correct. Just going to have to rewrite the substituted numbers right here. Okay. As you can see, our b is a negative. The b variable in this quadratic function is a negative, so we have to move the negative side as well while substituting variables for this axis of symmetry formula. Okay, so since we have two negatives here, as you may have already known in algebra, in order to get rid of these two subtraction signs, you basically just have to multiply. Okay, so negative times negative is obviously going to be positive. So once you simplify this fraction, you get 2. So our axis of symmetry will be x equals 2. Okay? Our axis of symmetry will be x equals 2. Now what about the vertex? The vertex always relies on the axis of symmetry. That's why we wrote the step-by-step process linearly. Okay? So the vertex always relies on the axis of symmetry. So now that we figured out what the number of the axis of symmetry is, we just have to copy the 2. Okay, just have to copy the 2 and then use the axis of symmetry to substitute the following unknown variables in this quadratic function. Okay, so that will happen by this, like this. Okay, so 2 to the power of 2 minus 4 times 2 minus 5. So 2 squared is obviously going to be 4, and this is going to be 8 minus 5. 4 minus 8 is obviously going to be, you guessed it, okay, negative 4. So now you have to subtract these two. Negative 4 minus 5, okay, it's obviously going to be negative 9. So our answer for the y variable in vertex is negative 9. Okay? So now here is where it gets a little bit tricky. The y-intercept. In order for us to get the y-intercept, we just have to make whatever the unknown variable is in this quadratic function. Okay? The x's. We just have to make the x's 0. Okay? And then our y will be whatever comes out of the quadratic function after we replace the x's to 0. Okay, so let's just do exactly that. Let me just remove this. So now we have 0 squared, 4 times 0, it's obviously going to be 0, so 5. It's going to be 0, and 0. What's left is negative 5. Okay? So our y-intercept will be negative 5. And we need to find the x-intercepts. The x-intercepts, they're practically the same, okay? But you need to factor the quadratic function first. So we need to factor the quadratic function by finding out what multiplies to -5 and what adds up to -4 as well. And just like the y-intercept, okay, whatever it's not asking for is going to be a 0. So the y is obviously going to be a 0 in both cases. So now we have to factor these two numbers. What multiplies to -5, okay, and adds up to -4? Well, we know that 1 times 5 is 5, right? But it is also the case for 1 times -5. So that will be -5. About 1 plus -5. Okay? How about 1 plus -5? That will be -4. So this will be the factored version of our quadratic function. So we just have to rewrite that as x. Okay. Let me just see if I'm doing this correctly. Okay. So we are doing this correctly. So our answer would be x plus 1 times x minus 5. Why is that? Because if you add, as you have already seen here, if you add 1 to -5, you get -4. If you multiply 1 to -5, you get -5. Okay? That's going to be our answer. First, I believe it's going to be negative. Oh, hold on. Okay. So now we have to isolate our answers. Okay. So now we have to know what the x's are from these two parentheses. So we need to use the transposition method by doing this. Okay. Just have to write it down. X plus 1 equals 0. Just have to make the other side 0. Okay, so x minus 5, x minus 5 equals 0. Now we have to transpose them in order for us to get our x-intercepts. Okay, so if we transpose this, what is going to happen is, or if we transpose 0 and 1 each other's places, there's going to be x equals -1. Then the signs will just change. Okay, x, if you transpose that, it'll be x positive 5. So now we just have to write that in. Okay, now we can see -1, positive 5. Okay, so now that we've completed this whole checklist right here, we know that the parabola opens up We know that the axis of symmetry is x equals 2. We know that the vertex is 2, comma negative 9. Y-intercept being 0, comma negative 5. And x-intercepts being negative 1, comma 0, and 5, comma 0. Okay, so now let's try to graph that into this little graph right here. Okay, so now we have to graph the axis of symmetry first. Let me just get the line right here. It says here the axis of symmetry is x equals 2. So then we have to draw a line on x equals on 2, okay? Now that we draw that line, let me just let's change the color. Okay, now that we draw that line and draw that point, now we have to use the vertex. So it says here that the x value of the vertex is 2. It's 2 as well. So it will say here, okay, 2 is already there. Now negative 1, we have to graph negative 1. Y-intercept being negative 5, we just have to hold on, being negative 5, this y-intercept. Okay. Vertex is negative 9, the y-intercept is negative 5. So now we have to use the x-intercepts. So x right here is negative 1 and positive 5. Negative 1 and positive 5, okay? Okay. Oh, I'm sorry about this. This is actually a mistake. The point should be here, 2, because it should coincide with 2, okay? Because the x is 2 and this is y, the vertex. So we just have to move that to 2. Okay. So the y-intercept, it's here right here. We just have to know what the last point will be, where the last point will be, and that will be very easy. Because as you can see, the vertex, the axis of symmetry right here is on 2. Okay. How many numbers is there? Okay. How many numbers is there? Is the distance? So we got 2, 1, and 0. Okay, the distance between them is 3. So then we just have to go 3 steps. Okay, or 2 steps. Okay, so I'm sorry about that. 2 steps. Okay, we just have to go 2 steps to that very same line. Go 2 steps from the axis of symmetry to the right. Okay, so 1, 2, this will be, it's actually 3 steps. I keep changing my mind. So it'll be right here. Okay. Negative 5, positive 5. Okay, that'll be the other y-intercept. Let me just see if it's right. Right in my assumption. No. It was 2 steps. Okay, so it's actually here. It's actually be the 4. Okay. So now that we've drawn out all of the possible points of the parabola, we just need to draw a line. Okay? And that will be our parabola. Okay. So this is just going to be one example. It's really more just like a introduction on graphing quadratic functions. But of course, as with anything, there's always going to be nuance to solving this. But hopefully, this gives you a pretty good idea on how graphing quadratic functions are with axis of symmetry, vertex, y-intercepts, and x-intercepts, okay? So, thank you for watching. I hope you learned something with this video. And have a blessed day.